Welcome. Okay, today we are going to continue on with this project. I'm not feeling too well today. I think I've got COVID because that's what it feels like. Not too bad, but I'm planning to rest up tonight. So, luckily, we've got a task we can do that won't take that long. We will create a CUDA error checking defined function, and we'll wrap that on all of the CUDA calls that we do. So not our kernel launches, but the actual um, functions that interface directly with CUDA. So let's get started. Okay, first thing we can do. By the way, any changes I ever make to this code, that's I'm gonna do that all live on stream, so it'll all be documented. We can go back and look at all of it. First off, I noticed this is a CMake variable, so in order to call it, we need the $sign and the curly braces around each side. The fact that it's white and all the other variables are green is it's a good indicator that something's wrong. Also, on we'll start running when we do our error checking. We'll only do error checking in debug mode. So we'll have a define like an if or else statement, seeing if it's in debug mode. And with CMake, we would typically, I mean, you almost always do it with and this is industry standard. Your build type you'll set to debug or release. You just capitalize the first letter, rest are lowercase. The way that Visual Studio works, when you're in debug mode, it'll set a defined variable that is underscore debug. So just like that. If you're on Linux, it's not going to do that. So we'll make it so whether it's on Linux or not, it'll and we're in debug mode, it'll define underscore debug. So let's see. I think to set a define in CMake, let's see, set add compile definitions. Debug. So in our code, we'll use underscore debug everywhere where we want our debug code running. So let's look at our other project, see if we have some examples of that, of setting definitions. Oh, that's right. We have to start it with an a dash D. Here we're doing it as add definitions. So let's see what the difference is. Add compile definition sounds more specific, so we should probably use that. Yep, looks good. Okay, we'll add that in. Also, let's add in our compile definitions for our compiler flags for C++. We don't have any yet, but let's just have the option there so it's easier later. All right, looks good. And we'll go ahead and we'll uncomment this, but our CUDA toolkit root directory, it'll be this directory, so we'll just have that uncommented. But we're only doing this if we're using Windows, so we can just use this flag here. And if we're using Linux, we will set the CUDA compiler location here. On Linux setting up NVIDIA, I've never seen a CUDA toolkit reference, so I think that's only a Windows thing. I'll go ahead and remove this from the commented out section. This was for something else, not part of CMake. Okay, so we go here, and on Linux, when we install NVCC, there'll be a symlink to CUDA. It should point to the latest CUDA that you have installed, CUDA version. It's probably the last one you installed. So you can just go to that directory and check and make sure it's pointing to the latest one. Looks like we have to do this before project, I think. And let's go back and we'll use a more descriptive function to set our sources. Let's see what that one is again. So instead of just setting a variable named sources with a huge list of variables, we'll use our direct source setting functionality. It looks like it's target sources, so we'll do that. Here we go. I think we need to specify the name, private. Not sure what private does, but we'll throw it in there. For include directory on CMake, you have to do this for some reason, but even the folder that the CMake list is in, you still have to refer to that directory as your include path. You would think that'd be there by default, but it's not. Okay, so this should work, and luckily now we've got our batch file to build this in Windows, or at least to set up the Visual Studio project. Okay, we're having an issue here. If string will debug. Everything before that looks good, which is good because this is the last command that we do. We could just check if this is ever defined in the first place. Let's see how we do it in my other project. Let's see how the internet says to do this. Here it's saying we don't need the $. But I like that it's lit up green. So this guy, at least, he's saying put it in quotes. So we'll see. Double quotes, that is. All right, we'll run it. Okay, great. It's not in this folder. Repos. Oh, we can delete our old folder. Okay, so yeah, in our build folder, now we have our Visual Studio solution. So for now, we're going to have to open up Visual Studio every time we want to compile it. And we'll fix that later. So here it is. It is set to debug mode, so build. Would you like to continue and run the last successful build? No. I never want the last successful build to run, because then I might not notice that the build failed, and I'll think that the old build is the current one, and that can lead to confusion with error messaging and things like that. So one build was skipped, one succeeded, and one failed. So let's see if what we want here is the one that built. I don't see it in here. What is it saying? Oh, it's that issue we had earlier. CUDA toolkit. Wrong project. So this should be set here. Let's make sure that this is actually getting tripped. Also, while I'm here, let's make sure I'm actually live streaming. I am good. Get rid of the clutter. I'd like to print a message to confirm that we're actually this Win32 is defined. We're actually going down that path. Let's see, in this project, I think that is how we do it. Yeah, if Win32, so it should be going down this path. All right, so we print a message just with the message command. And there's various different message types you can have. Like for instance, you can have an error one, it'll stop the CMake process if it encounters it, but we just want a status message. So let's make sure that's happening. Project is building for Windows. Good. So try to run it again, reload, and we'll go for a build. This is unfortunate. This is the error we were seeing yesterday that CMake was spitting out. And now we're seeing it in VS, in just regular Visual Studio here. So let's close the project again and we'll delete the build directory. It wasn't able to delete it last time because it was open in Visual Studio. So with our batch script, it should delete, delete the build file, build folder. Here we go, open up the solution again. Let it load all the way. Same error. Maybe we can, now we're in Visual Studio, so maybe we can just set that setting. I'll just set the single startup project, the AI art generator. That's what we want. What if we do release? Oh, yeah, same error. Okay, we fixed it. Another thing we did last time that fixed the error was we opened this project up in code and scanned for kits. But we've already scanned for them. Here we go. Oh, okay. Now it's giving us the 2022 here. It wasn't doing that for us 2 nights ago. We'll just do generic scan for kits. It says no kit selected, so let's do AMD 64. 2022 Visual Studio. Okay, we'll run CMake again. And let's see what happens. Open it up again. Same thing. Maybe I should just restart my computer. I haven't done that in a while. This is so strange, it's right here. And we know that it's... We know that it's going into this conditional because we have this message printing out. Let's see if this is in fact the correct directory. Should be. Oh, doesn't recognize that. Yep, this is a directory. And MVCC should be in here. Sure is. we're doing this before we say which language we're using. What if we do it after we create the project? Oh gosh, close this. Sometimes it takes you over to the output screen here, but we want to be in the terminal. Okay, so close this. Go to our repos folder. Oops, I was talking on mute for a second there. Just checking my live stream right now. Oops, I was talking on mute for a second there. Just checking my. Whoops, muted. Okay. Build. Alright, well, we'll Google this. No need for that. Whoa. Okay, it's saying this guy suggests running NVCC directly through the command prompt. Checking that cl.exe is there. CL is like a compiler and linker tool for Visual Studio. The actual compiler is MSVC for Visual Studio, so it must like connect to that somehow. Okay, so there's a few things we can do right now. One is we can just put this in here. We'll just tell it exactly where MVCC is. Another one is we can set those variables that we had set the other day. I've got those in a text file somewhere. We'll okay, reload all. Actually, we'll just close this again. All right, we got it. And build. Build. Ah, it's the same problem. Okay, let's try setting those system variables again. Where do we have? those saved. Nope, not the desktop. I could have just looked at my last stream. Is it in the repos folder? Yep, here it is. Okay, so we can do CUDA path. All right, I've got the actual Windows pane up on my stream now, so we can see how I do this. Environment. This option comes up. Edit the system environment variables. Come here, environment variables, and down here we'll add these. So it was CUDA path. Let's see if this caps lock thing. Yep, the caps lock thing shows up on my stream, so you'll see whether it's there or not, or whether it's on caps lock or not as I toggle it. That's how it is in there. Before, you don't need the quotes or the double backslashes. Okay, so this one, CUDA path v12. CUDA path v12. How's that capitalization? Oh, it's v12 underscore 0. All right, and then we gotta close down our command line. We'll shut down Visual Studio again too. Close it so it can register it again. It's so weird, it's not. That 2 nights ago, the error was popping up with CMake, but now it's popping up on Visual Studio. All right. System can't find the all build file. Let's see though. I have a feeling our binary will be there. Nope, not there. Yep, here it is. Sweet. All right, so I'll open this up. Alt D, select the path of the folder I'm in right now. Control copy Windows CMD. Enter. Paste. Oh, actually, CD. Oh, we need quotes, double quotes, because they're spaces. Actually, there aren't spaces, so we didn't need that. All right, we'll run AI art generator.exe. Hello, CUDA. That, if you see, is exactly what we wanted. So our project is building and running. Thank goodness. All right, so we're ready to make our error checking. So we can do this through Explorer. I'll just show you how to do it through VS Code. And before I do that, I wanted to talk about 2 nights ago, AstroGrep. It wasn't finding all the files that I wanted it to find. We were looking in this directory, and I noticed that it wasn't finding, actually, yeah, it was exactly what I just had in. It wasn't finding this Visual Studio executable cl.exe. So I search, and I know it's in there, but it didn't pop up. So we'll let it search again. This was really disturbing because if the tools you're using to find files don't work, you could think something's not there when it is, in the middle of like some bug hunting venture extravaganza, and then you'll start looking for other solutions to the bug when really it was just that the file wasn't there. So we need to know if the file's there or not. So I found out, I looked back at it. If we look at the bottom here, it's there's like a yellow highlighted section. if we double click that, it's showing us it is here, but it was excluded from the results. I think that's because it won't find executable files. I'm not sure, but it does tell you that it's there. So if you ever get that prompt that comes up, your search has your search yielded items that were either excluded or cause it, your search yielded items that were either excluded or cause an error. You can check here, and it'll show you. There must be some type of setting somewhere. Can we find it? See if there's anywhere where it's specifically excluding executable files. I don't see anything. Nope, not sure, but it comes up down here. All right, so this will be a utility. So we'll make a folder for utils. And this will be an error check. Should we put all our error checkers together, or should we separate out the CUDA one? We'll separate out the CUDA one. So we'll name it error check CUDA.hpp, and we'll make it the same thing again. We'll make an implementation file as well. So you can press F2 to rename it, then just Control A to select it all, and then we'll make a CU file for the implementation. So each and every CUDA call, it returns an integer that it's typed up as some type of CUDA error status thing. So we can wrap every CUDA call around in a function we'll make through the preprocessor that'll read that integer, and then we can output. Instead of having a logger, we'll just have everything output over the console. So first thing is, we only want to do this if there's if we're in debug mode, because it's gonna take CPU cycles to check all this. So if it's not in debug mode, that means it's in release mode. We will take our function and we'll set it to just nothing. So what should our error name be? Or what should our function wrapper be? Not function wrapper, but function that we wrap, that we call the other functions into. Let's do CUDA check. So we're defining a CUDA check preprocessor function that takes an input, and what it does is it just runs that input, so it does nothing. So no wasted CPU cycles. Else it must be in debug mode. So we're going to define CUDA check x as calling a function that will take in the result and explain what the error is and where exactly it's occurring. So I get to come up with this function name, CUDA call checker. CUDA call check. So it'll run the function and then take the result in. This $x, that'll give us the name of the function. This will give us the name of the file that this preprocessor call will be in, and then the line number as well. All right, that looks good. This might grow, so we'll put a comment that this is for debug mode. So we will make a function for CUDA call check. This first value here, that'll be an integer. Well, it'll be the CUDA error status. To see that, we need driver types. This is from NVIDIA. See if the code navigator can take us there. No, it can't. Maybe if I include CUDA runtime.h. No, it won't take us there. Let's see if our main file, if we put it there, it'll be able to find it for us. It does find it for us. I don't know what the difference is. It could be that our main is linked in the CMake. That CMake extension looks through your CMake file. But we don't need a header file there though. In this CMake file, so I don't know why I wouldn't be able to find it through here. But let's have these here in our implementation file as well. Maybe if I include our file here, what I like to do is keep all the paths, like the relative path of every file that we use, stated in the code. So instead of like in the CMake saying that we're going to include something, we're going to include a folder that's like several layers deep and then that'll have our include files. I'd rather just have every thing that we include have its specific directory listed anywhere that file is listed. Error check CUDA.hpp. Yep, it finds it. So let's see what our CUDA error type is. Oh, this is a big file. CUDA error, here we go. See, here's all the different types of errors that can be put out. CUDA success means nothing went wrong. That's a 0. Everything else is a positive number. So here's our type. It's listed a lot. It's probably type def somewhere. So we can use regular expressions. Nope, guess not. Let me check my old project to be sure. Oh yeah, CUDA error _t, which does have a type def CUDA error. Oh, that's right, because of the flavor of regular expressions we're using here. Instead of just this wildcard, I forget the name that it uses. here for its regular expression language in the control find. But if you want 0 or more of something, you have to put the character in, and then you put the wildcard after it, and that means 0 or more of this character. And the dot means any character. So instead of like with astrograph where just star means 0 or more characters, we have to do any character 0 or more. And then also on our directory wide search here, this uses a different regular expression language than it does over here. I think this is equivalent between the two, but this one I think is PCRE2. Let's check that. Visual Studio Code regular expression language. Visual Studio. Oh, this is Visual Studio, not VS Code. Here we go. Oh, it says it uses Rust regex in the find replace in the file sidebar. Oh, and they use rip grep, which is a program written in Rust. I don't know Rust. I really want to learn it, but that'll definitely be after this project. Rust is the future, apparently. I'd say we've got about 5 years though before it's big. Before you can actually get a job knowing Rust. But ripgrep is awesome. It works on Windows and on Linux, probably Mac, but it's a very fast grep utility, and it uses Rust regex. So in the file widget, it uses a JavaScript regex. Okay, so if we really need to do some advanced stuff, we can look into the specifics of each of these. All right, let's get back to it. So we'll say CUDA error underscore t result. This comes in, I think it's as like a C string. So we'll do const char star function name const char star file name that this call is made in, and then const char star line number. We'll put an underscore to clarify. I think file name just one word. This is my stream. I get to look at whatever I want. Here we go. It's file name one word. 2 words is an adjective or a noun when referring to the name of a file. Don't hyphenate. Usually 1 word when referring to a programming term. Okay, so if you have like a literal file in a file cabinet made of paper, then it's 2 words. I like these Coke Zeros. It's like 0 calories and 40 milligrams of caffeine. It's like not too much. Coffee's got typically like 150 to 200 milligrams. Little too much for me. All right, so then we'll implement this in our implementation file. So it's 0 upon success. So if result. So now this, there's all those different types of error messages, or yeah, types of errors that we can have. So we need a function, or we need a lot of text to describe all of these. So I have that in my project here. Oh, not here. I have it here. Oh, I use a switch statement here. But it just returns the name of the error. Oh, and this is an H file, so we'll do pragma unts in the beginning for our include guards. So in our implementation, oh, this is returning the string. Yeah, we can have a separate function here that'll only run if there is actually an error. std string CUDA return error string CUDA error t error, because this will only run if there's an error. Okay, switch. Switch error case CUDA success. Oh, actually we could run this if it is successful. Okay, I guess we'll just leave CUDA success in there, even though this will never get called. We need our string include. We need our string function or library. Standard library string. No, let's take out CUDA success because that'll never. Well, I guess we could say maybe the video will change CUDA success to not be 0. That's never gonna happen though. But that would be a justification for leaving it in. So I guess we will just actually do that. Okay, if result, we can run this with our result. Well, but then we won't get in the if statement if there. I'm gonna take it out. There's no need for it. Oh, and this goes up to CUDA 8. Let me double check and make sure that there's no more errors here because we're on 12 now. NV link uncorrectable. Oh, look, yeah, there's more of them now. Illegal address. I think that one's been around a while. Yeah, and that's here. These aren't necessarily in order. Let's just app failure base. We'll just rebuild all of this ourselves. So we're gonna take all of the possible errors here and copy them out. Do some magic. You don't need CUDA success. Boom. Alright, so we'll make a new file, paste this in. Control A. We'll get them all buttered against the left. And we just want to get rid of all these comments, so we'll do Control H. Anywhere we see that, we'll get rid of it, and then any character 0 more times, ending in this. But there can be, it can go between lines though. That's fine. Okay, well, let's remove all the spaces in the beginning. The upward caret, that means the beginning of a line. So it starts with the upward caret arrow deal, and there's a space right after the line starts, which we see here. See how there's all these spaces here that it's not finding? It's only these ones. So we'll get rid of all these because we're replacing it with nothing. Now we'll take anything that starts with a star. Oh, the star has to be need the escape sequence. So backslash. And then all the way to the end of the line. So any character 0 more times. We'll remove that, and then we'll remove the new line at the end too. So let's see how that looks. There we go. Okay. Now I'll remove this. We need a bunch of escapes here. 2 of them actually. Okay, and then the new line at the end, we'll get rid of that too, so it squishes it more. And then anywhere where there's 2 lines next to each other, we'll remove that. Boom. Oh, no, we don't want that. We just want to replace it with 1 new line. Here we go. Boom. Okay. Wow. So here's the name of all our errors. How many do we have here? So 95, line 95 starts at line 11, so the 85 minus 1, 2, 3, 4, 5. So that would be 80. And here we've got, it's 126 now. Okay. Oh, this one sticks out here a little bit. We need to set it up like the other one. So we start it with case. Oh, we still got some of these. All right, yeah, now they're all ending in spaces. Okay, so we'll have case, then we'll have a colon and return, and then we'll just have it all again. Okay, so how are we gonna do that? Actually, we'll just remove all spaces. Oh, except we want the one with the case. We'll do spaces 0 more time, but then it has to be at the end of the line. There we go. End of the line means you have to use the $sign for that. These spaces are at the end of the line, punk. Boom, dead. Okay, so what we can do now to get spaces here that are all even. Well, actually, first let's box select like all of these, so we can copy all the names for when we make them into strings. All right, now we need to block select them all again, and we'll just do end. Now that brings us to the end. Create a bunch of spaces, and then we can just block select again, cut out all these spaces. Oh, first we wanted to we wanted to put colons here. Okay, so now we put in all the spaces. Bingo bango, delete them all. See how much space we got here. This one sticks out most. Alright, we return, and then boom, we have our block select here. And automatically put in that ending double quotes. So, and there, boom, line number done. Line ended. And let's double check that does match our format. Yes. Sweet. And we don't need these comments. We'll just we're using CUDA 12 or later every time. Alright, so just Control A, everything. There's no new line at the end. Bam. Alright, indent it one. Looking good. And then if it doesn't know what the error is, return unknown. In case we forget to upgrade it for CUDA 13. Okay, so this returns a string. Our errors, we're just going to put them out through the console, so we just need IOStream, which includes string, so we don't need string. So say CUDA, so now we're typing our error message, CUDA error, errors. Standard console out, CUDA error, our string. And we take from the other project the rest of this message. Oh yeah, we could put out the number itself too. So standard, so yeah, these lines are so long, you need the double left arrows. I love the way Python does it. Rust does it really well too, where you can just like when you're making a string or a message, how you can just put the variable name in the middle of the string. I think you use like the $sign to do that. So actually, as you're reading the error message, you can just look at the name of the variable, and it's easier to read. But it's not like forever long because of these bit shift operators that are been overloaded. Oh, and then we'll just say file name. Line number. Bada bing, bada boom. We won't like do an exception or anything and like stop the program. Well, we could. Yeah, we'll just see it on the console. Okay, so we get our string here. For the error, get the number. A comma here, so it's more uniform. File name, line number, and then next line. Return. Of course, we need to include the header for this file. I just call that file header. Include. And because it's within our project internally, we use double quotes to include. To get the file, to get its relative path, you can just right click and go to copied relative path, which is Control K, Control Shift C. Oh, I'll try that. Control K, Control Shift C. Seems like a lot of work though. It's a big ass hotkey sequence. Huh, why can't it find it? Is it because it's expecting different directory separators? This one's working. Art utils error check CUDA.htp. Says cannot open. Oh, we were supposed to use the Linux one? What? Nope, still not working. Oh, regardless, we gotta put this into, maybe because it's not in the CMake. Well, I should still find it though. Set sources. Oh, okay. These are the Linux separators. Okay. Oh. The fix it. So we'll use the Linux separators. Okay, good. Then we don't have to change these includes for compiling for Linux. Oh, and it's finding the CUDA runtime and driver types now. So we just need driver types to get this CUDA error _t. So, and we do need that in both of these files. Okay, so back here. So if not define debug. So if define debug, define CUDA call check, and I'm gonna call that. I think this should be good. Compare it to my last one. I have it returning a bool for some reason here, even though I don't see why you'd have it return a bool. Oh, it's static. Yeah, I guess we could make it static. No reason not to. Also, I have an assert CUDA. Oh, right, because it's only gonna run if it has an error. And then here, before I was putting in debug rate, this underscore debug break, this only works in Visual Studio. So we need a multi-platform solution. Okay, yeah, I'll make them static. Oh. Oh wait, no, because it's... I can make this... I'll just make this one static, because it's only being used in this file. Let's see, I'm returning a string here. I've done this, but I don't remember for some reason. I just haven't done it in a while. But can we return like an actual like char array as a string? Or does it have to be a char star? I'd rather use string. And then this will be a string. I'm sure we can pass a string into the cout. We don't have to do like dot c underscore string. I know it. I just know it. Okay, so I'm in output now. It takes you here sometimes. Gotta go to terminal, and you can always just hit the hotkey Control Accent aigu right by the one to the left of it. And oh, build file's written. I gotta pee. Alright, it recognized that it changed, so let's reload. So we don't have to shut down Visual Studio and open it all the time. I don't think we'll have to. I was doing that a lot earlier. Thank God I got an NVMe solid state. Build. It's building it. Still getting this error. The all build. How about we just don't build this ever? Can we do that? I don't want to look up what all build and zero check are. Because we've got our AI art generator, so that succeeded, I think. Let's see. Build. Okay, 11:35, 11:35. Yeah, that just filled. Yeah, let's just delete it. And remove zero check. So it's filled again. Oh, and it runs it. Oh, and it doesn't shut down the console automatically anymore. Thank you, Visual Studio. All right, it's filled in. Now let's test out that it works. That's a good step to do. We'll run a CUDA. CUDA. Oh, we don't. We do have it included. CUDA error check. Oh no, just CUDA check. Small and simple. CUDA check. There's CUDA device synchronize, I think's the name. Yeah. So we'll run that. This you call it like it holds up like all different streams of different kernels you can have, because you can have like 2 kernels running at the same time if they're both small enough to all fit on the GPU, and they're on different streams is what they call it. They'll stop it. It'll wait for everything to be done on the CUDA device synchronize. Call. What else is it? Oh yeah, also like your kernel. If you run a kernel and then you have a bunch of CPU code after the kernel runs, it'll run all that CPU code like before the kernel finishes. Because why wouldn't it? It's happening on the CPU, not the GPU. But this will stop all CPU and code from running in your program until the kernel's done too. So it's good. It's good for error checking. And yeah, obviously you need it sometimes. It'd be cool if we could just turn it off if we're in release mode too for some of them. We can think about that later. Define CUDA check as CUDA call check, which runs this, which is here. We got the squigglies. Define CUDA expands to. Why do we have the red squigglies? I don't want this actually to be named CUDA call check. Let's do like CUDA check expanded. That's like a better, that's more accurately descriptive. CUDA return error string. Yeah, that's good too. I like having like the prefaces all prefixes be like pretty general and get more and more narrow. I think it's cool, except for it's bad for autocomplete though. It's better to have like the first 2 or 3 characters be unique and then autocomplete faster. But in my mind, for organization, it's better. So I guess we'll just mix it up. So I could have it like check CUDA. Yeah, just for autocomplete. I can just name it check CUDA. Then whenever I type in CH, it'll. We'll think about that later. It doesn't say. Oh, CUDA call check is undefined, is what it's saying. Oh, okay, I did a control save all. CUDA check expanded. CUDA check expanded. It's like, it's not updated. Maybe it'll update when I run CMake. Damn, my computer is handling this streaming great. 3% CPU usage. I'm encoding the video with the NVIDIA graphics card. That's gonna help. Damn, man, I'm uploading at 6 megabits. Average time to render frame 0.9 milliseconds, and we're only at 30 FPS. Well, that makes sense then, right? So about 3% of the time we're rendering, 3% CPU usage. I still have 51 more hours too till my disk is full. In which case, I'll just get a newer NVMe. I got a 17-inch laptop actually. I might be able to fit 2 NVMe's in there. Okay. Build files written. So we'll get back here. I do want to do all of my coding on here. I might do some research off stream though, like look up how to just compile it without using Visual Studio with the actual application, only its compiler. Oh, failed. We're done with this. We close this file. Don't save. Okay. Yeah, I gotta remember to. Oh, that's the problem. I gotta remember to, push this to Git by the end of the stream. We're almost there even. Okay, so save. Argument of type if is incompatible with type const char star. Const char star. I'll get better at enunciating. This just needs some practice. How now, brown cow? The Human Torch was denied a bank loan. Okay, int. This should take in CUDA error t. Error CUDA return error string. If result. Okay, let's see. I also got this other error here. Max reg count equals 0. I mean, it's an error because it's got that red X here. Oh, it's just saying it exited with code 2. That might be from the first error. Okay, I don't remember. So rebuild it, or make it. Okay, SLN solution reload. It said there was an int error. Okay, now here's our int error back. Okay, so where are we putting the int in? This is an int because it's an enum. Enums are signed integers. Const char star, const char star, const char star. Function name. Oh wait, we didn't put our function name in here. Function name. Oops. No, that's fine actually. Function name. File name. Line numbers. Int. That's the only place I think we need to update that. Okay. Reload and run it. Main.cu line 14. That must be where CUDA check is. What else we got? So, oh, yeah. Of course. See, make it again. Solution it. Reload. Hello, CUDA. Okay. So we actually ran it, and it worked. Well, didn't spit an error out. Which shouldn't. So how can we induce an error? Here's something. So you can't do CUDA check on your kernel, because it doesn't like return, the CUDA status. But if there is like an issue in your kernel, you can run like CUDA check right after it on some type of function, and then if there was an error in your kernel, it'll come out at that time. So it's like it's like queued up in some buffer, and then next time you try to get the error, or next time you do a CUDA call, it'll pop that error out of that CUDA call. So we could like run how many threads can run in a block? Let's see here. CUDA maximum number of threads per block. If we run more threads than is compatible. Okay, you can only run 1024 threads. Okay, and then I don't remember the you can have like 3 or 4 input numbers when you launch a kernel. I don't remember which one's threads per block. Probably the first one is number of blocks. Second is threads per block. Let's check that. CUDA kernel call format. All right, read the documentation. N is 1, bit shift to 20. That's a lot. Where's the kernel call? Saxby. Oh. Course. Yeah, okay, threads per block. So we'll just say we're running, well, I mean, I think so. We'll run 1025 threads. We'll deuce an error. Girl, you want to come over to my apartment tonight? We'll deuce an error. Oh, it's actually not erroring out. Let's try to do something in our kernel then. Oops. You can actually print F out of your kernel. So first let's get our thread ID. Well, we only have one block, so our thread ID will just be our index. So to get the number of our thread, like within the kernel that it's running, we can use this keyword, this CUDA keyword, thread index IDX in the X dimension, because we can have like up to it's either 2 or 3 dimensions of our threads running, which I'll go over that later. But typically I always do it in 1D. It's faster. There's like some internal math happening if you do it in 2D that makes it slower, so we'll just do it 1D all the time, and if we need it in 2D, we'll do that ourselves. Okay, so we've got our ID. I'll explain that later. I'm just trying to do this right now. So just like a standard printf. So F for formatted print. Looks good. I think C out has an exception, so it's std out, and that's why we can't use it in the kernel. I've always only seen it printf, so pretty sure C out's not supported. I can see C out having an exception too. Yeah, if you put in like some crazy variables. Like why, you know, actually why would it compile and then not be able to see out? I don't know. Let's see. Does C out have exceptions? Nope, can't throw an exception. C out in CUDA. Trying to see if we can do C out in CUDA. I've never seen it. Oh, I guess first we'll do this. Prioritize. Didn't work. Alright, I'm closing down VS Code so that I know the build folder gets deleted. Okay, it's not deleting build. There's got to be something we can do where we can stop it. Oh, it's because we're still... Wait, no, it's not there. Where are we using it? Okay, I'll delete it manually. We gotta put in the batch file something where, like, if it can't delete the build folder, then then it'll just stop the script. Says it's open in Visual Studio, which we closed. Maybe check the task manager. So by name. Look up Microsoft as we sort it. It's not there. Can we do like can we search this? That'd be cool. If we can search like which processes are running through this menu. On our task manager. Nope, it's not a task manager. We'll delete it through VS Code. Resource locked. Here, I'm gonna move these notes. This is for a video. Right here, so it's cleaner. Oh, it's because that console is open. It was just on the AI art generator directory though. Okay, here we go. I need to try like looking at the camera more. Like if I'm gonna explain something or have an emotional outburst and I don't need to look at the screen, I should start just looking at the camera more. All right, built. I mean, project generated. All right, it's loaded. Let's run it. Check my screen. That old builder. We've been seeing that. That's not a problem. Yeah, the other one's built. So let's run it. Open up PowerShell. I'll show that again. So you hold down Shift, and then you right click, and then you get the open PowerShell window. You've got to click in a blank area, or what happens if you click on the file while right clicking? I mean, and holding Shift. It says edit with Vim. You get the path here. I found that out the other night. But it doesn't say open with PowerShell. So you gotta click outside of any file names. Shift, right click, open PowerShell window. AI art generator. Hello, CUDA. It's not giving our thread numbers. Global mic IDX, printf. And it has a CUDA device synchronized here, so it's not like it's going to return 0 if it hasn't run. Okay, so let's do simple CUDA print example. Looks pretty similar. Arch compute print.cu. They're running 10 blocks, 10 threads per block. Oh, look at this. Printf output is stored in a circular buffer of a fixed size. If the buffer fills, old output will be overwritten. The buffer size defaults to 1 megabyte and can be configured with CUDA device set limit, CUDA limit print, FIFO size, first in first out buffer size, size T size. I don't know what circular buffer is. I know what first in first out is. That's like a key where you read from the front. I got a pen. I've got this laptop that has a touchscreen. It's a Lenovo Yoga, and um, it's really cool with the touchscreen. It has a specific pen that's compatible with it, where it's pressure sensitive, and it's got a button you can erase what you're writing on it. I also got another capture card. They're really cheap these days, these capture cards, but I can input that laptop's output of HDMI into the laptop I'm streaming with, so I can draw on it with a pen. We're definitely gonna need things written down to do like the back propagation algorithm and the forward propagation, um, lots of concepts and stuff, and we can go over like how the reason I think of it, we can go over like how different buffers work, like vectors and FIFO queues, double ended queues. That should be cool. I should take my drawings too. I could save them, and then we could have those as architecture drawings in the Git. Nah, nah, that's too hillbilly. I don't want to do it in PowerPoint. I used to do 2D CAD, um, not for drawing up software architectures, but for another thing. And that programs would be awesome for drawing architectures, but it's kind of expensive. Um, and PowerPoint is just, it's really, I really don't like using it. It's like, it's missing so many features. The interface is clunky. You can't really blame Microsoft. They only have like billions of dollars and only had like 20 years with the program. It's hard for them. I try not to be sarcastic too much. I'll do it with super rich companies. So this looks the same. I'll just. Oh, I need a studio. So let's add that in. I always put my standard libraries first. That includes first. Studio. Stud.io. Actually, that's probably included in IO stream. Or like through a chain of includes. Evolve core. We'll see. I'll retry it. And then we'll put in comments for where all these includes are coming from. Project headers. Make it clean. Let's. Whoa. What? This looks really cool, but I don't know how this came up. Oh yeah, it's showing me like what hasn't been committed yet. I don't know what I pressed. I want to set up another camera on my keyboard and mouse because I do know a lot of hotkeys. I used to play StarCraft 2. And that stuck with me. And CAD. That's another great thing about CAD. AutoCAD LT, which is a 2D version of their AutoCAD software. It's got a lot of hotkeys. It's like you can do everything through the console. You can make scripts and run it too. But yeah, my brain is forever more wired to like learning these hotkeys. But instead of explaining them all, I can just show them through a camera. Okay, how do we get rid of this? And I wonder what I pressed to get that up. That's probably part of the get lens extension. All right, let's run it. Build. Build, yes. Okay, all build error. The error message sounds probably annoying for stream. Yeah, I'd like to set it so different applications can and can't come through the stream. I don't know if I can do that. And I'm not writing my own plugin. We're doing this. Can I just run it through here somehow? Yeah, if I build here, it's up to date. It's not running though. Open in terminal. CD debug, AI art generator. Oh. I swear it's this setup. Setup is always such a pain. I've worked at companies though, really big ones, and the guys that can actually like do everything from CMake, you know, like really complicated projects and stuff, and they fix all these types of errors. They're like really critical to the company, so it's good to learn all these things. But it's always a pain in the ass. You have to be really patient. I mean, you've got to be. Oh, I should put in a new line. You've got to be patient enough for software, but this is another level. But usually you do it at the beginning of the project too, so it's like less time pressure. A lot of programmers like they only know like the basics of CMake and all that because like somebody sets it up for them and they're not like moving files around the project or anything like that. They're just the project already exists and they're modifying the code that's in the existing files, and in that case you don't need to know CMake really. Which means, yeah, most people don't bother to learn it, but somebody has to know it. So it's good good career advice. Learn CMake and Visual Studio and Make, perhaps Ninja. Maybe it's just not running because it's exceeding the number of threads that is supported. It didn't remove the build folder, so if this doesn't work, then we'll close VS Code and then make sure the build folder gets deleted. Reload. I don't know why I ran that again. Should have done that. Okay, but let's just try it. Oh, no, okay, we have to rebuild it. Rebuild. 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 And run. There we go. Look at all these numbers. Whoop. Oh, no, they're gone. Oh, no, they're just on the left. Okay. So I think I can zoom out. Yeah, so hold control, scroll out. And this is 1080p, so we don't see them much. But as you can see, like, they are launched out of order. It's not just 0 to 123, it's each warp runs independently. It appears like within the warp they're running in order. The warps, whoa, down here to here. The warps they're not guaranteed to run in lockstep on touring. But it looks like they are. Yeah, let me just check. 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7. And that's 32. But yeah, they're so within the warp they're running in order, but the warps run randomly. You know, so yeah, parallel computing, CUDA. That's how you get this crazy performance, and that's what you need for deep learning. See, it's almost like I knew which tools to use for deep learning. But this is disappointing though, because I guess it's not that much. Like we're not gonna make the mistake of running too many threads in a block. But what I was hoping was happen though is that like the kernel would run, have an error, and then when this CUDA check ran, or CUDA device synchronized, then our CUDA check would pick up the error and it would output it. But I'm guessing that F12 to navigate. F12. I'm guessing that there's not an error for like too many threads per block. What can we do? Oh, you know what? Let's just make a pointer in the kernel. We'll just make a random pointer. Int pointer. Invalid pointer equals 0x 5. And then we'll say so we're gonna do like an invalid address, and we'll assign it to a value. This would compile in C equals 42. There we go. I love how we just have all the threads, like, all tackling this one memory address. But the graphics card won't let it. So yeah, CUDA doesn't have exceptions, so what the hell? My computer will probably just blow up. We'll see. Compile. Ever. Yes. Okay. It worked. I've got fast eagle eyes, so I already know it worked, but I'll show you guys now. Yep. Type. There we go. Caps lock off. CUDA error. Does this look familiar? To the observant, it and those with good memories. This well, you need both of those characteristics, but this is happening because we wrote this. I wrote this. I want to say we. It's more like, I don't know, it's friendlier, but it is me doing this. Unless you're following along. I'll just assume everyone's following along. Our error message here, CUDA error. CUDA error, illegal address 700, function name CUDA device synchronize. Right, so it didn't actually happen in that, but it was it happened in the kernel before that was called. File name C. That's not right. Oh, yeah, it is because it's C drive. File name C drive user. Okay, full screen. Main.cu, line number 25. Hello, CUDA. Hell yeah. Let's get our file name, line number, function name, and the error. Okay, good. Actually, though, we didn't set it to run in debug mode, now that I think about it. So how's that work? Oh, because we built it, yeah, in debug, so it'll automatically put that in. Okay, so let's do a release. Let's see what happens. Here we go, build release. So in our build folder, there's the bug that has a debug executable, and now we've got our release in the release folder, release executable. Shift, right click, open PowerShell window. Look at that. No error message. It didn't output all the thread IDs because an error happened. But no error message because we're in release mode. Okay, but just for just so that it's always released, we will do we're going to pass in the release type. Not the release type, the build type. I think you do that with like a -d type, and then the name. It's kind of weird because it's the same formatting they use for the compile definitions. Like if you were passing into GCC or G++ or Clang or whatever, the way you pass in a define, like a preprocessor define, to the compiler through the command line is with a -d, but I guess it's the same way to just set a variable in CMake, which is different than a define. Well, maybe not necessarily. So I guess anything that you have defined also comes up as a CMake variable. That's something to look into. Let's become CMake experts. Let's see if this comes up. This MSVC, if that's just like automatically there. Building for Windows with MSVC. Then we'll do other message, just the status message. Okay, so we'll do. I'm not really like completing my thoughts very well tonight. So so if it is debug, we'll have a message that says that it's debug. So message, and it's a status message. Building in debug mode. Message command. Building in debug. Every time I save it, it goes to this output. Oh, and it's like configuring and building every time I save it. So like if I just put a space here and save it, I don't want it to run this every time I save it, but we'll do that later. Okay, I need to make a list of things. I've kind of got one started here. AI art. I've got a little bit of a list. Okay, CUDA error checking. We've done that now. Alt-Shift-5 to strike through. I think of it, I remember that hotkey because 5 kind of looks like an S, which is what strike through stands for. So we'll see. Find out if all CMake variables become defines. F2 to highlight, and then it'll automatically, if you press F2 in Excel and in Google Sheets, it'll automatically put the cursor at the end. It'll put you in edit mode with the cursor at the end, which is very convenient. Okay, so next, what did I just say? What else are we gonna find out? Oh yeah. Let's see, like turn off automatic CMake run after each CMake lists .txt save. I just don't feel like it right now. Why do we put these quotes here? I guess I would think that if this is saved as a string, then once you like dereference it or like pull the value out, like it would automatically like be a string, unless you would need to put the double quotes around it. I think with CMake you can run like command prompt stuff. I wonder if there's like if that's done in a special way to make it extra cross compatible, because that's another awesome thing about CMake is it runs on Mac. In fact, for the new Macs, the Apple Silicon, it runs natively. It doesn't use Rosetta. It runs on Linux and runs on Windows. I wonder if it has like some type of generic like command line interface scripting that you can do within functions. All right, so I'll run this. We'll see if it says it's building in debug mode. Nope, it does not say that. So perhaps then with our batch file, what? Oh, I never saved it. I shouldn't open it in Notepad. Okay, here we go. Now we run it. All right, yep, says building in debug mode. So this is right. -d CMake build type equals debug. Cannot specify compile options for target add. Do I need to have like the project name in there? Oh yeah, probably this stuff like target this project with this. Nope, it's like turning all red here. Okay, so we'll just look this up, or we can look in here. Add compile up. Wrong file. Control A, Control C here. Control F, Control V. Boom. Oh, no results here. Okay. I think I know a database that'll have something about this. Google servers. I add compile definitions. It just says definition. And I think you use an equal sign to assign the defined variable. So if you don't have the equal sign, then it will just define that it exists without a value though. Definitions are specified using the syntax var or var equals value. Yep. They could have said it as well as I did. Add compile options. With compile options, you can define things, but that's bad practice. Okay, so this command can be used to add any options. However, for adding preprocessor definitions that include directories, it is recommended to use more specific commands. Yeah, always use the most specific command possible in CMake, just for anybody else that looks at it. And this only is for the current directory and below, so like this is in the root directory, this CMake list, but you can embed CMake lists down further in the directory structure. And so like some of these commands like only apply to the files there and below. It's really, I think they should have done a better job, CMake, like thinking it through, because it has to be named CMake list.txt. And so if you're trying to find one, then like they all have the same name, and it's really annoying. Like you kind of lose track of like which one is where, is if you're like looking at a bunch of them at once. So I wish they did it better. It would have been cool if like with the file name it ends in CMake list.txt, but then you had to like prepend all of like the above directories to it. And then I don't know how you do like a directory separator, but have something for that. That'd lead to really big file names. There had to have been something better though. Or at the top, you have a command that says like what directory it's in, just for reference for everyone looking at it. Yeah, that would have been cool. But you'd still have to scroll up to the top all the time, like if you're looking through a bunch. Okay, so let's look at an example. So in this example, OpenCV version equals $ curly braces OpenCV version. So there's no like project name in there. What was that other one? Target compile definitions. Actually, we'll just look at it. Oops. Okay. We'll search. I don't remember how to get on the page. Target compile definitions, yeah. And then you put in the project name. Interface public private. Let's put that on our to-do list. Look up meanings for in CMake. Let's get this problem solved and then we'll do that. Well, actually probably a different stream. Oh, you don't have to have the -d in. Yeah, we'll do target. Because that's really specific. That means it's specifically only for this executable. Oh, this is our problem. It says add here. When did that happen? Oh, this has been the issue the whole time. Okay, we'll do it this way. We'll do private, and then we'll do that. And that's alright. It wasn't like we were just looking at this bug this whole time. We were learning things. Building in debug mode. We'll just make the capitalization match here. I was talking on mute. Okay, so it works in debug mode. What I was just saying is that this is interesting because I set it to release and build it, even though in our CMake batch file we set it as debug. So if we try to build release, yeah, it doesn't work. libcmt. Okay, invalid parameter reference and function. There's no, oh, just allocate? Yeah, 2 unresolved externals. CRT debug report. I think CRT, RT is runtime, I think. So like core runtime, it's like a Windows thing. So yeah, it won't build with release when you set it to debug. I don't want to look into what these are. Let's make a mental note of them. Also, what I said I was gonna do is like, when I was on talking to mute, try to turn off Visual Studio sound through my mixer, but doesn't show up. Oh, application system sounds. Boop. Off. Yeah. Okay, good. It's not making that sound. Things I do for y'all. Okay, so it's in debug mode. So, and it can only be in debug mode. Oh, right. Okay, so because this is debug mode, I should rename this. Debug. And then we'll copy it. And then just hit F2 to rename. 02 Windows CMake. Release. Which it probably defaults to, but we'll just type it in. So these target commands, they have to be after you add executable. But we do want to know like early on, like when in our messaging that it's in debug mode. So we'll put another statement up here and get rid of this. Control Shift K, I think. Yeah, that just deletes one line. All right. Alright, debug. I'm all over the place tonight. Okay, AI, boom, run. Illegal address. Sweet. Alright, well, let's check this bad boy in, but not with the induced error. Okay. Control X-on-target. Get status. So it thinks we deleted this, and then we have an untracked one. Oh, maybe if I get at all, it thinks we deleted this batch file. But if I did get at all, maybe it'll know that it was renamed. That would be better if it knew it was renamed. No, it doesn't know it was just renamed. I think it has some type of functionality. I've seen it where it knows when you just rename a file, and I would assume it has to do with like the similarity of the internals to it, and not the similarities to the name. And these should be pretty similar, but it's not registering it. Okay, new file settings.json. Oh, we don't want our VS Code specific stuff in here. Okay, so in our git ignore, we'll ignore it. Config. Okay, we'll be specific. It's config directory, so that's our build folder. It's more than config. It does have a lot of config in it though, and then VS Code, which is purely a config directory. Okay, so save that, and then now let's look at the status. Modified. Git ignore. Yeah, this is beautiful. So far, so good. I'll talk more about this later, but I don't really know how I want this series to go. I'm still thinking it. As I get more viewers too, we can all decide together. But I don't know like how much I'm gonna go into tutorials or how much we're just gonna bust through the coding, or I mean, it could just be medium level granularity with the educational component, or it could just not really say anything about coding, and then we could just purely go through deep learning education. That's not going to happen. I like to teach people things, so. But my point though is like I'm not sure the exact direction that this will all go, and we'll talk more about it later. But yeah, I'm gonna start thinking about it. I'm gonna heat up my dinner. Okay. Okay. All right, we're ready to commit. Git commit message added CUDA. What do you call them? CUDA? I've been calling them CUDA calls. think there's a better name for it. Like CUDA specific API calls. Maybe if I hover over it, it'll say. What? I'll just call it CUDA function calls. Added CUDA function call error checking. Utility. And get push. Sweet, and I'm still logged in. Cool. Okay, so I showed you how to do this quick, but you can also get it from the GitHub now. Let's double check that it's there. github.com Livestream AI art generator. Yep, these two are here. It's gonna be there for sure. Okay, cool. Okay, and that'll be it for tonight. It's a shame I'm sick because usually after work I'm like really tired because I just coded for 8 hours, so I was kind of looking forward to the weekend and having more energy. But I ended up sleeping for 12 hours and still not feeling too great. But I would love to just do this for a long time some night. I'm not some night, but someday. I'm busy tomorrow though, so I won't be streaming. Anyways, yeah, thanks for joining me. Leave any comments, suggestions in the YouTube on the YouTube video, and yeah, you check out my my Discord I made. It's a public Discord now because I'm not a big channel at all. But yeah, eventually it'll be restricted and all that. But yeah, if you join now, then you won't have to pay to get in or anything later on. And with all that, have a good night or day. Enjoy yourselves. Bye.